Bismillahirrahmanirrahim. Welcome students, welcome back to our course. My name is Muhammad Javed Siddiqui and this is for Mechanics of Materials. I'm going to discuss with you today how you're going to analyze the data that we have got for the stress strain diagram that we discussed for the 4 material samples that we tested in the laboratory, namely the brass, copper, aluminium and steel. So I'm going to share with you the readings as promised, and I will also share with you how we are going to draw the graph for these different specimens and how we can compare the different properties of the material with respect to the stress strain diagram. So let me take you straight to the data that I have gotten the force in kilonewtons. Remember, the unit is kilonewtons, and using which we will be able to calculate our stress. How we will do that, I will just let you know shortly. And then here these are the change in length. First of all, let me start from here. This is the delta L in mm. So for every change of length of 0.1 mm, there is a recorded force in kilonewtons and the deformation in mm. So this is the change in length from 0.1. So this is the interval that we tested, 0.1 mm of change in length. For every change in length, we have got the data for the force for different specimen and the deformation. So here we can calculate initially. Remember students, the specimen was initial length of the specimen between the two punch points here was 30 mm if you remember. Then the initial diameter of the specimen was 6 mm. So once I know the diameter of the specimen, I can find out the area, which is 28.27 millimeters square. So that is the area from the diameter of the specimen, which is 6 mm. Initial length of the specimen between the two punch points was 30 mm. Also, obviously, we know the stress formula. Stress is force by the area, and the strain is nothing but the change in length by original length. So for all these values here, students, for example, this is the delta L. I can determine the strain in terms of the percentage from the formula change in length by original length. So I can just put it in the Excel is equal to, okay, I actually have done this here in the solution part. So let me share it with you. How did I do this? I said this is equal to change in length divided by the original length, which is the 30 mm. Obviously, I don't want this Excel to move down when I'm going to scroll this one. So I will put an F4 here so that the initial length does not change. So every time the change in length, delta L will change, but the initial length, which is 30, will remain the same. So I have added a dollar here, and I'll press OK, and then I'll say this is a percentage. These values are percentages, so I will pull this down and I'll get the answer. So let me do it in a empty sheet here so that it's clear for you. So change in length divided by the original length, which is here, original length, and of course I'm going to put dollar signs here, and then I say that it is a percentage, so answers will be in percentages. So I'll just pull this down. So these are my different strains at which I will check my stress. So next, now let us move the different materials here. Let us start with the aluminium. I have force in kilonewtons. Then I have to calculate the stress. So stress is equal to force divided by the area, which we have calculated from here, 28.27. Again, I don't want area to change every time I go down with the force values. So I will write here dollar signs. So but remember students, C3, which is the force is in kilonewton. I want the stress values in Newton per millimeter square. So millimeter square is the area, So to convert kilonewton to Newton, I will multiply the whole thing with 1000. Multiply, sorry, the screen has changed, let me put it, yeah. So multiply 1000, this is the value of the stress in Newton per millimeter square, and let me just pull this down. Yeah, so these are my values, so these zeros are not required, I can just delete them. Now these numbers I can format them to show me simpler ones, because it shows a lot of digits after the point. So I say format cells, and then I say number and 2 digits, 2 decimal places. Now this is simplified. So here strain, we don't need strain every time, strain is common for all of them, so you can actually delete this, only stress is required. Similarly, you can calculate the stress in terms of the copper material. So this is force divided by the area, again force divided by area, again area, I'll put a dollar sign, and then I'll multiply the whole thing by 1000 to change from kilonewton to Newton. So that again is the stress value of copper. So rest of them are zeros, so this is enough. I can format cells, I say number again, I say OK. So these are my stress values for copper. So similarly, you can find out for different materials here, which is brass and steel. So you have aluminum, copper, brass and steel. Now let us see how to draw the graphs. So if you look at drawing the graphs, I have completed the sheet for you here, stress for each of this material, aluminum, copper, brass and steel. So it's very easy now to draw the graph. So I'll select this, go to insert, scatter plot, and I have the graph for the steel. Similarly, you can draw the other graphs for other materials. I will select it for brass. Now of course you can draw all of these graphs in one single graph, but I'm drawing it individually here. It is up to you whichever way you want to go. So again, scatter plot for brass, for steel is here. Next I can select the copper, insert, scatter plot. This is for copper here. Scatter plot, and this is for copper, yes. So steel, aluminum, brass. Now aluminum is remaining. I'll do the same thing for the aluminum here. Scatter plot again, this is for the aluminum. So this is how you generate these graphs, students. You can put all of these graphs into one single graph to compare them. So just to show you, these are the 4 graphs that we have generated for aluminum, steel, brass and copper. So I will share with you this worksheet, students. Complete the stresses and find out the strain, the stresses, and draw the graphs and submit to me as a report. And then I will also give you a worksheet wherein you will identify the yield point, you will identify the yield stress at that specific point and the ultimate stress and all that. So you will identify, I will give you an empty sheet, you will fill the data and submit it back to me. So I hope it is very clear to you, students. If you have got any questions, you are always welcome to contact me through email and visit me in my office. So thank you so much, and see you again in the next class. Thank you.